Hello, I am Taha Muhammad, USA Court, Iraq. I solved Collatz in 3 ways. The first way is 10 pages. Okay. The strategy of that first way is I didn't go what is the sequence of 1, what is the sequence of 2. No. You cannot do that and has no end. And immediately I went to loop. I told, okay, let the loop numbers maybe has 1 element. And I prove it is wrong. 2 wrong. 3 element, figure out by sketch, by pattern, by equation. It is yes, true. We have, and those 3 are 4 to 1. Okay, somebody told, what about if maybe some numbers have a number of loops 4? I said, okay, let me try. And I used my equations, patterns, everything, and rule, and it didn't work. It's wrong, failed. And anyway, I was able to find the pattern, equation, induction, everything. And now the rule is this. If number of elements 3 and multiple of 3, then they have that all integers have the same loop 4 to 1. For any number of loops, not 3, not multiple of 3, not divisible by 3, then there is no loop. I tried this is entire natural numbers, this pen. This entire natural number from 1 to infinity. Divided two group. Group of numbers divided by 3, yes, has a loop. And numbers of not divided by 3, no loop. Then what does mean that? It means for any integer, another line we have n, another integer, for any n I iterate, then they have only 4 to 1, and you can look at my first way. And 10 pages I cannot describe it without the board, without you are sitting. Suppose you are sitting and I describe it. But now I am going to describe second way. Maybe you will be comfortable with that. Second way, only 1 page. Do you see that? 1 page. How I started. Collatz definition, you know what's the rule. Even divide 2, odd multiply by 3 plus 1. Okay, but you have to know this fact. This is my copyright. Taha's Collatz fact 1. When you have a sequence and elements are A, B, C until T or no end, we don't know yet. But the important thing is, if it has a loop, then has a stop. Okay, then the fact is this. The loop of any integers in any side. First side we have n. Second side we have A, B, C, T. All loops are the same. This is the fact that I figure out. Then let us start solving it. From 1 to 5, as you see, loop is 4 to 1. That means we have a set, name it u. Any integer in this u as the loop is 4 to 1, as you see. Go to 1,000, million, by machine, you can do it, then you get that. But what about after that? Okay, I went until r minus 1. Then I told, what about r? And this r is r over 2 if it is even. If it is odd, multiply by 3 plus 1 goes 4 to 1. That means this r for even and for odd also work it out. I told, the loop is 4 to 1. What about after that? Okay, And listen here, see, I'm telling you LSN equal that, and Z equals goes to the R, and R, I told you here, let make it even. This R, let make it even, not odd. Okay, therefore, I will start 3 sub 1. I go one more term. After R, we have R plus 2. When we have 10, then we have 12. We add 2. This is even. Is the loop for that also that? See, asking, is the loop R plus 2 equal 4 to 1? I came to number, take it here, use the sequence rule. This is even, divide by 2, you got that. And continue, you don't know what will happen. Just put that and stop. Because R plus 2 is even, I told you, that's why we divided by 2. Okay, then, because this is sequence, go to Taha's fact. What is that? Any element in the right, in the left, equal loop of any element of the left, of the right, I mean. See, the loop of R plus 2, same as loop of R plus 2 over 2, and continue like that. But this number is small, smaller than R. That means we come to this sequence Z, this set Z. When this is R, we have R. Half of it will be before that R. Any element here is 4 to 1, the loop. See, the loop of this, 4 to 1. When this is 4 to 1, therefore, this one also 4 to 1. That means for all n equal 4 to 1 for even. I told for even only. Okay, what about if we have n odd number? Don't worry about R plus 2. No, we come to odd number because we did proof n plus R plus 2 is good. What about when n is odd? When n is odd, then multiply by 3 plus 1. Taha's fact, the loop first side equals loop second side for each element. Okay, what we know about this, 3n plus 1, because this is even, any even, I told you, is 4 to 1. Okay, 4 to 1 by 3 sub 1. This is 3 sub 1. 3 sub 1 is any even is 4 to 1. Okay, but that even, this one, is equal to who? Loop of LSN, the odd. That means odd also equal to this, 4 to 1 for all n odd by substitution in equation 2. Therefore, loop of any integer is 4 to 1 for all n belong to n plus by 3 by 1 and 3 by 2. 3 by 1 and 3 by 2. Thank you very much. Bye-bye. You can stop it, the video, and you study it, please. This is my second solution of Collatz.